Improvement and extension questions on the limits of accuracy. First thing to say here, guys, is please attempt this using green pen on your own first, and then if you then need to watch the video, pause it after I've gone through a little bit and see if you can then work out the rest of it. And can you also note that you've done it with support? So that being said, I'm going to go through the solutions to the improvement question and the extension question here. A cuboid has a volume of 5,000 centimeters cubed, correct to one significant figure. The cuboid has length 14 and width 18, correct to the nearest centimeter. So again, to start with, I would probably draw myself a little sketch of it. I'm using a ruler. I might not if I was just sketching it out in the exam just for time reasons. I might not bother with the ruler. You know, I might actually be better at sketching without a ruler. I'm not sure. I might be, you know. Anyway, kind of this is behind, so it's not perfect, but yeah, you get the idea. So there's my cuboid, and I know that this cuboid has length 14 and width 18, correct to the nearest centimeter. So it could be 13.5 to 14.5 this way, and it could be, you know, 17.5 to 18.5 this way. You probably get a mark just for that. Okay, and I want to try to figure out what is the height. And I want the smallest possible height. So this is where your sort of common sense thinking starts to come in. To get the smallest height with the same volume, the length and the width would have to be as big as possible. Imagine something very shallow but extremely long and wide could have the same volume as something with a very small base but very tall. So just as a little sketch to kind of help you see that, you know, these might have a similar volume. Something with a small base but very tall, a cuboid with a small base but very tall, could have the same volume as a cuboid with a very much bigger base, but not much height. Those could have the same sort of volumes, couldn't they? So the bigger these are, the smaller my height would have to be. Okay, so also if I want the smallest possible height, I don't want a lot of volume to begin with. The less volume I can have to start with, it'll be easier to get the smallest. I could get a smaller possible height. So my minimum height is going to be my minimum. Well, first let's think. It's length times width times height. Isn't it? That gives me volume. So my height is going to be my volume divided by my length times my width. Okay, and my minimum height is going to be my minimum volume divided by my biggest possible length and width. So the biggest possible length is 18.5 and the biggest possible width is 14.5. So my minimum volume here, my minimum possible volume is 4,500. So I've got 4,500 divided by 18.5 times 14.5, and that will give me my minimum possible height. So my minimum height is, let's put that into the calculator, 4,500 divided by 18.5 times 14.5. 16.775 and so on and so forth. So 16.77539.609. I'm going to just leave it like that. I haven't said in the question, you know, what degree of accuracy I should leave it to. So I'm not going to round it because I want my absolute minimum. And if I start rounding it, I'm not giving my absolute minimum. So I'm going to keep all of that for my minimum height. That's what it is. Right, extension question. So just pause it anywhere there if you want to really get your head around it. Extension question. I can carry 30 kilograms, correct to one significant figure. If the cuboid has a density of 800 kilograms per meter cubed, correct to one significant figure, what is the maximum possible number of cuboids I can carry? I think there are a number of different ways to approach this, but the way in which I'm going to start to approach it is to think about how much one of these cuboids could weigh. And if I want to carry a lot of them, I want to think what the minimum possible weight would be. So the minimum possible weight, okay, so mass, that's my weight, isn't it? The minimum possible weight is going to be density times by volume. So my minimum possible weight so my minimum mass is going to be my minimum density times by my minimum possible volume. That makes sense, doesn't it? It's going to be light if there's not that much of it, minimum volume, and it's quite airy, minimum density. Okay, so my minimum mass is going to be, right, my minimum density. Now here we have to be really careful, and I did put this in as a bit of to trip you up, really, and they will do that in the exams as well. I gave this in kilograms per meter cubed, but I gave this in centimeters cubed. And we need to think in 1 centimeter cubed, sorry, in 1 meter cubed, how many centimeters cubed are there? And this is where you make the mistake unless you think carefully. Here's a cube, side length 1 meter. 1 meter by 1 meter by 1 meter. Now that 1 meter by 1 meter by 1 meter is also 100 centimeters by 100 centimeters by 100 centimeters, isn't it? Because that's what a meter is. So 1 meter cubed is the same as 110,000, 1 million centimeters cubed. Okay, so you need to be really careful of that. So what I've then got is I want to give my volume in meters cubed, right? So it's actually 5,000 divided by 1 million meters cubed, each one. Okay, so that's 5 thousandths, or 0.005 meters cubed. Yeah. And my minimum density, oh, hang on, careful, I went with 5,000, but it's not, isn't it? Because my minimum volume is 4,500 and not 5,000. So it's 0.0045. And my minimum density, correct to one significant figure, would be 750 kilograms per meter cubed. So I'm going to times these to get my minimum mass. So here we go. 750 times by 0.0045. I want the minimum mass because I want to be able to carry as many as I possibly can. So that's 3.375 kilograms. That's my minimum mass. So my minimum mass, and I can carry 30 kilograms, correct to one significant figure. So to improve that, so maybe I can carry as much as 35 kilograms, right? So I could carry between 25 and 35. If I want to carry as many as possible, I can carry 35. So how many 3.375s, which is each cuboid, can I carry in 35? That's what you're finding out. So 35 divided by 3.375 gives me 10 and a bit. Okay, 280 over 27, 10 and a bit, 10.370, okay, recurring. So that means that the maximum number I could possibly carry would be 10 cuboids, right? Because that's the maximum whole number of cuboids. Presumably I can't split the cuboids up. There's my answer.